In this video, how to use a master sketch and why you might want to do that, as opposed to using a spreadsheet and why you might want to do that. And then we'll also talk about why you'd want to use a spreadsheet and why you might not want to use a spreadsheet for your designs. So we're going to cover all those topics. So a master sketch, what is a master sketch and how do you create one? Basically, the way I consider a master sketch anyway, is you have a sketch of the item that you want, a two-dimensional representation of the item you want, and you use that to drive the dimensions for your model, much like you do with a spreadsheet. However, it depends how you visualize and how you prefer to visualize. I personally, when I'm creating models, I'm typically designing at that time. I'm not just creating something from a sketch. I'm creating something where I'm actually making design decisions in the model itself. So I don't always know what the end product is going to look like. And so creating a master sketch is probably not something I would do normally. But for the sake of this demonstration, I'm going to show a fairly simple sketch. I'm going to highlight this guy and just get rid of it. And what we're going to do is we're going to create a sketch of something that looks like this. And I'm just going to draw it freehand first. I'm going to draw it in projected, a projected drawing, so you'll be able to see what I'm coming up with. So if I start here, I'm going to switch into my construction lines now. So my construction toggle is this guy. And now I'm going to project this center line. I'm going to make that horizontal. Remember, my construction lines are blue, and I'm going to project it vertical. Just do it down to here. Let me get that vertical. And then I'm going to create another line that's going to come off here, and it's going to go up at 45 degrees is what I want to do. So that's, we'll just do it there for now. And I'm going to constrain that guy with an angle. And I'm going to make that 45 degrees. And I am going to extend that line down to there. That's not what I wanted, because I have a constraint here where they're stuck together. So let's have a look at that constraint. I'm just going to deactivate that. And then I'm going to extend that line down to here. So that's what I was looking for. So that allows me to project over to here. So then I know I'm going to have a shape that looks something like, I'm going to go back to my regular lines. So the toggle for construction and regular lines is just this box where it goes from the blue construction or the white regular line. So if I click that, they go blue. Click that, they're white. So I'm going to project this guy over. I'm going to do some constraints on it first, I think. Actually, I'm going to do that first here. I'm going to take this guy and this guy, that point, and make that symmetrical. And that's just so that this square shape or this rectangular shape is symmetrical around the center point of these circles, and those circles should be connected together, and I want that one to be smaller than that shape. So if I project this shape, essentially what we're going to end up with is something that looks like this, and I'm going to say to there, and then this guy is going to be something like this, and then something like this. So now you can see that this shape projected in this direction will look something like that. I'm going to give that end a dimension here. I'm going to call that, as it's that size, I'm going to call it 100. And now I'm going to say this dimension here, call that 50. And we're going to dimension this diameter 40. And we're going to do this last dimension here. And I'm going to call that 65. Now remember, this is a master sketch. So this sketch, I don't have to constrain it. I don't have to have it completely constrained because I'm not going to model from the sketch. I'm literally just describing the part that I'm going to be creating. So, so I know then that this dimension is going to be 100. This dimension is going to be 50, and this dimension is going to be 40. So what we're going to do is we are going to constrain these with symmetry around this line, and this one is going to be with symmetry around this line, and this one is going to be symmetry around this line. So now I can see that as a projection of this. All I need to do is to make sure that these dimensions are the same. So for this particular piece, I can dimension here, and I can just make that a reference dimension. Or actually it doesn't matter because it's not the same as that dimension there. So let me do something differently. I'm going to take this dimension and I'm going to give it a name. So I'm going to call that dimension SQ height. So that's my square height is what I'm calling that. And I'm going to give this one SQ width. And then I'm going to give this one a dimension of large diameter, and I'm going to give this one small diameter. Okay, so I have those dimensions are now all given parameters, given names, so that I can reference those dimensions. I'm going to just bring that line down a little bit just so I can project across. And so what we're going to do here is we are going to trim this line back to here. So I'm going to trim it back to here. And then I'm going to take another construction line and I'm going to go, now remember when we point to this guy, the X comes on, that means it's connected to there. I'm going to come over to here, make sure it's horizontal, and then I have a projection line from here. And now all I need to do is to create that same shape. So I'm going to create the rough shape first. And this will be what it looks like in the other projection. So I'm going to take those 2 points to that center line, go with symmetry, go with symmetry, and more symmetry. That's just to keep it centered around these center lines. So now I need to join these guys with a vertical constraint. And this one. So now, without creating anything here, I have managed to make these a vertical constraint. And then I know that this dimension here is going to be equal to constraints dot small diameter. And I know that this one, I need to catch the right one there. Is going to be equal to constraints dot square height. Notice these dimensions go in as blue because they are reference dimensions. They're being referenced by something else. I'll just move this up here just so you can see it a little easier. And then this one is going to be equal to let's say constraints. You have to tell it where the dimensions are. So constraints, large diameter, say OK. Now, one tip for that is when you're creating those reference names, use all lowercase. If you mix case, when you come to reference them, you have to use that same case. And if you can't remember, if you capitalize every word or if you capitalize the beginning of words, it becomes a mess. So it's much better if you create your reference dimensions in lowercase. Now I know that this is a diameter, so I'm going to take that and just make them equal. And I'm going to take this guy and this guy. I'm careful to catch the line there and make those equal. And then I want to take that inside guy and this outside guy. Can I get that line? There it is. Say equal. Oh, actually, that's not equal. Let's go back and delete that constraint. Last constraint. And just delete that one. Because that is not equal. It's going to equal this. So we need to dimension that one. We're going to dimension this. And we're going to make it constraints dot square width. Sometimes the parameters pop up, sometimes they don't, but when you actually get it right, it pops the result in there so you can see it. So that kind of helps you. Okay, take that dimension off there. So now we have that dimension so we can see it. So all I've done is I've created essentially a technical drawing of this part. And what it does is it describes to me what this part looks like. And I do need some lengths now on here. I'm going to make that 40. And I'm going to do a length on here. I'm going to make that 100, because why not? And I'm going to do a length on here. And I'm going to make that 45. And again, we want to go into these ones because these are going to be driving dimensions and give them names. So we're going to say length, large, diameter. So now that one is called length, large, diameter. This one is going to be called length. And it's going to be square. And this one, bet you can't guess, length, small diameter. Okay, so now I have one sketch that describes my part. If I bring that to the middle so we can see it a little bit. I know it looks a little messy. There's a lot going on here, but I have my part fully dimensioned now so that I can create a model from it. Now I can't create a model from this sketch because I'd have multiple parts, and those multiple parts are not allowed when I complete my sketches. When I do my padding or whatever I'm doing, I can't create multiple parts in one body. So I'm going to create this body from this master sketch and literally use this master sketch as a driver. So I'm done with the master sketch. I'm going to close it. I'm going to rename it. And I'm just going to call it Sketch Master, just so I know which sketch it is. And you can see my sketch there. I don't need to see it on. I'm going to actually turn it off. And now I'm going to actually create the model from that master sketch. And that master sketch is really just a way to describe the part that I want to make. Okay, so to the actual models or the sketches that are going to create the model. So in XY plane, the first part I'm going to create is just that back piece. And I'm going to dimension it. And here's where we use the master sketch. So we say sketch, and you can see it right there, sketch master. And we say constraints. And then we say large diameter. And so that piece is driven from that master sketch. I'm going to close that, and I'm now going to pad it, and I'm going to use this, and I'm going to say sketch master constraints, and I'm going to say length large diameter. And to make my life easy, what I think I'm going to do is I'm just going to reverse that pad. So it's now on that 0, 0 plane. So that piece is now created from that master sketch. If I go into that master sketch and change those dimensions, it's going to change this pad. So now I'm going to create the next sketch, again on the XY plane. And this one is a simple square. I'm just going to constrain it around that center point because that's where we need it to be. And I'm going to give it 2 dimensions. This one, which is going to be sketch master constraints and square width, square width, square width. There it is, SQ width. Say OK, and say OK to that. Then I'm going to give this a dimension, and I'm going to call this sketch master constraints square height. And we're going to close that, and then we're going to pad it. And this time we're going to pad it sketch master constraints length square. And we say OK. You're probably starting to get the picture now. So the final thing we need to do is to create the third sketch. And we'll go with a circle. And we give that a dimension. And this is going to be sketch master constraints small diameter. Say OK. Now remember, this one is drawn on this plane here, so we got to offset it by the height of or the length of the square. So let's do that. So we go into our attachment, and we say our position and our Z position. And this is going to be sketch master constraints length square. Say OK. And now my sketch is up here, or it should be. And then we're going to pad this sketch. And we're going to say this is going to be sketch master constraints length small diameter. Okay, so now we have this part that is completely driven by a master sketch. So if I go back into my master sketch and let's change some things, let's make this 50 and we'll make this diameter 150. Okay, so everything is growing, and now you can see this part has grown too. So everything is now driven by the master sketch. I don't have to go back into these parts and do any changes. You saw these sketches for these individual parts are super simple, but I have one sketch that shows me the shape in 2 dimensions, admittedly, of what it is I'm creating. So I'm going to make that back down to 100. And to be honest, from an engineering standpoint, from my standpoint, looking at a 2D drawing like this and being able to change it is a little easier than changing it in a spreadsheet. However, if you name the items in the spreadsheet in a logical manner, you can visualize this type of sketch. So if I close that again, you'll see my model changed again, and it's changing based on that master sketch. So it's making that master sketch, or that master sketch is driving this model. And so you can see that it's a pretty straightforward way to modify something like this. Now, one thing you will notice is the complexity of this sketch. Not that it's any more complex than having to create these parts separately, because you have to dimension them and you have to come up with everything's dimensioned from a drawing perspective. You know, from a way to create this, you're going to have to create a sketch for it one way or another to create a model. This is good if you think in 2D, you want to project your 2D drawing and you want to be able to create a model from that 2D projection. This is a great way to do it. However, I think as it gets more complicated, you may start running into some difficulties in building everything in one big sketch. And of course, I can't create a model from this sketch because of the separate pieces in the sketch. I can't constrain this sketch in a way, or it's not worth constraining the sketch in a way that you would normally constrain sketches. It's not, that's not appropriate here because this won't be a model. But these dimensions will drive that part, and I can create, you know, whatever shape part I want by just modifying these dimensions. So this has merit. It depends on how you come up with your sketches. I personally am trained as a draftsman. I did that a long time ago. And so 2D projections and creating parts is not difficult or strange for me. But if you're new to creating parts and creating models and creating drawings, this may not be the way that you want to go, because it does appear more complex, even though it's really just an amalgamation of all the simple parts that you would do separately when you create the model. When you put it all on one screen, it can appear complex, it's sort of busy. And so it may not be for a beginner who hasn't done any technical drawing and doesn't have the 2D or the ability to take a 3D piece and project it out in 2D. This may not be a great solution for them. So let's create the same part, but use a spreadsheet to create that part. So what I'm going to do is I'm going to create a new body, and I'm going to switch this body off so that we don't have this in the way. And then inside this body, I'm going to go into the spreadsheet workbench, and I'm going to create a new spreadsheet. And we'll open up that spreadsheet. And what we'll do is we'll create, in this spreadsheet, we'll create the dimensions that we want to create. We'll actually do them in this spreadsheet and get it all squared away here. So let's do that. So the first thing we had was large diameter. And again, when you're doing this, it's better to use all lowercase. Small diameter. We had the square width and the square height. And then we had length square, length large diameter, length small diameter, and I think those were the only things we needed. So if you haven't used it before, there's a macro that allows you to alias these names into this column. You can do it manually if you want to. However, it's much easier to use the macro. So to use the macro, I'll show you it real quick. We're just going to go into our macros, and it's called easy alias. It's this guy here, and we just execute it. If you don't have it, it's actually a macro that's available in the library. So you can just click on this add-ons and go and download Easy Alias. So when you execute it, what it does is it creates aliases for these. So now this guy knows that it's connected to this large diameter. This one knows it's connected to the small diameter, etc. So from the perspective of creating those aliases, I highly recommend using that macro. Just there's no reason to do it manually. It really doesn't make any sense. But just for completeness, I'll show you how to do one of these. I'll create a dummy here. We'll call it, we'll just call it height. I'm going to do it like this, just as a dummy. And then I go into this one, I go up here, and I create it as height. And now this is linked to height. If you watch at the top here where it says alias, I click there, it says height. I click here, it says height over here for the content. So if I click this one, the alias is length small diameter, and that's that one. If you watch over here, length large diameter, length square. So manually creating them, you just have to go in and type everything over there. There's just no point in doing that. With the Easy Alias, I would strongly recommend using that. You just select all of them down here. The only gotcha is you have to have the spreadsheet selected. If you don't, it's going to throw an error. But other than that, you're all good. All right, just from memory, we're going to put in some numbers in here. So we're going to say that was 100. I think that was 40. The width was 40. I think that was 40. And this was 30. I don't remember. The length of our square was 100. The length of the large diameter was 40. The length of the small diameter was 50. So we'll go with those numbers. They'll kind of make sense. Actually, I'm going to make that 45. Sorry, no, I'm going to make that. I want it to be smaller than that square, so I'm going to make it 25. There we go. Now it'll fit inside the square. Okay, so that's our spreadsheet, and we're going to just save this. Now we've got the spreadsheet done. We're going to go back to this body, and to switch between the spreadsheet and the model sheet, you just come down to these tabs, click that. There's my regular model sheet. There's my spreadsheet. If I want to see them side by side, I can go into this Windows and I can say Tile. And now I can see my spreadsheet and I can see this sheet. However, in this case, I don't want to do that because I want this guy so I can draw my sketches first. All right, so let's go back into our part design workbench. And we're going to create a sketch on the XY plane. And you guessed it, we're going to put in that big circle. And we're going to give that a dimension. And now on this one, we're going to say spreadsheet. And we're going to say large diameter. Say OK. Close that. And we're going to pad that. And we're going to pad it for spreadsheet. And we're going to say length, large diameter. And reverse. We're going to make the model the same way. So reverse that. I'm just going to expand that so you can see where my sketches are all going. And so then we're going to do the next sketch. The next sketch is going to be XY plane. It's going to be that square. And then we're going to put those dimensions on. So this is going to be spreadsheet. SQ width. Okay. And this one is going to be the vertical dimension. And one thing to note with this little guy here, you can select this little formula editor guy, or you can just hit equals and it'll pop up. And then if I type spreadsheet, I can go down arrow, pick the spreadsheet, and I can say, this is square height. So I can just use my down arrow to pick that. I don't have to keep going back and forth with my mouse, and just say okay. We'll just zoom in there just so you can see it. Remember to get, if you're in the dimension cursor and you want to get that off, you just right click, that turns that off. Then I'm going to close that and I'm going to pad that guy. And again, I can say equals, and I can say spreadsheet. And this is going to be length square, enter, enter, done. And I'll say okay to that. And then we got one more sketch to do. So we're going to go XY plane. There's going to be another circle. Give a diameter. I'm going to say equals spreadsheet. And we're going to say small diameter. Say okay. Close that. We're going to do that offset again. So in the Z, it equals spreadsheet length square. So now my sketch is actually sitting on this plane, and I didn't draw it on that face because that would give me a topological naming issue potentially. So I'm just doing an offset of the sketch, and then I'm going to pad it, and I'm going to say equals spreadsheet, and this is going to be length small diameter. Now I have a model that's driven by the spreadsheet, and so I can tile these in my window, tile, and I'm just going to center this guy just so you can see it. And then I can go into my spreadsheet and I can modify this to 150, and I can modify this diameter or this square width to be 60. Type 60 instead of 50, 60 and 70, and my small diameter to be 40, and my lengths. So there it is, driven. It's the same model. It's driven now by a spreadsheet instead of a master sketch. So you can decide which is easiest. One thing I will say with the spreadsheet, one thing that makes it easier to navigate is making sure these names make sense for you. So heights and widths and lengths are all things that you need to know which way do they go. So you can equally assume that this from here to here would be a height as opposed to a length. But what I did is I assumed everything going this way in the Z plane is going to be a length. So I called it the length for the square, the length for the small diameter, the length for the large diameter. And I actually went through and put large diameter rather than LD and SD, because sometimes you don't keep up with that. In fact, where I put SQ width and SQ height, I probably should have put square height and square width, just to make it easier to understand. So you can see from a spreadsheet standpoint, it's very easy to change it. The thing I like about the spreadsheet is you could make multiple models driven from one spreadsheet if you were doing things like I have this part, and each part has different parameters. So I could create a second table that basically describes this part, and then make a model that shows the second parameters. I think that's a little easier to do in a spreadsheet than it is in a master sketch. The master sketch has the advantage of you can see the whole part described in a two-dimensional drawing, the entire part as opposed to just the small sketches. But me personally, I would use the spreadsheet over the master sketch nearly every time. And so I just find it easier to create something this way. Now, that being said, when would I use a spreadsheet or not use a spreadsheet? So for me, creating a spreadsheet driven model is really about, am I going to be creating this part in different sizes? If it's a one-off and I'm never going to create it with another or a different size, or the modifications I'm going to make to it are very minor, I'm not going to use a spreadsheet. And the reason for that is, as I said before, I don't always know what my part is going to look like before I've created it. So I'm using the model as a way of designing. So I'm creating things as I go along, and I don't always have all the dimensions in my head until I start looking at the model. So if I were creating this part and I was only going to do one of them, I wouldn't use a spreadsheet. I would just model that part with this. I would probably do the same model because you need to create these as separate parts. There's not much on here that you can do all in one sketch because they're different geometries and different pads. I did see a question from somebody who was trying to create something similar to this all in one sketch by sketching these shapes and then extruding in different directions parts of the sketch. You can't do that in FreeCAD, not yet anyway. So it's much simpler to just create those very simple sketches. Now, let's say this part had to have holes in it. If I go back to the beginning of this sketch and it had holes in it, I could just create the holes here. So let's do that. I'll just create a couple of holes. And just so they look the same, I'm going to make them equal. And of course, there's all kinds of things I could do to lay that out, but I'm not going to do it for the purposes of this. I just want to demonstrate. If that had holes, you see I'm just building it up just gradually. That's what makes FreeCAD, in my opinion, makes FreeCAD easy to use, is that you create these models from very simple pieces. Don't make it overcomplicated because that's going to hurt you in the long run. The best way is to make these simple models, and as always, leave all your radii and chamfers and things to the end. And that way, if you have to change anything and it messes up the radii and chamfers, you can just delete them and add them back in. Again, when I'm creating a model, I'm generally designing the part. So I'm not using spreadsheets as much as if I were going to do 25 of these parts, but they're all a little bit different. If I was going to do that, I would definitely use a spreadsheet to create it. Now, if I wanted to add those holes and I wanted to put those in the spreadsheet, I can go in here and modify it and add those dimensions. So if I say, I'm going to call this small hole, and I'm going to call this small hole center. So if I wanted to just add those, I can do it this way. One thing I don't like about manually doing this is if I mistype this guy, I'm going to mess that up. So I'm actually going to copy it, go over there and then paste it. And then I know that that is correctly done. In case there's any typos, just paste it. So there's a couple of manual ones. So if I made that small hole diameter, let's say 10 to start with, and the center is going to be, so I probably need to calculate that center, because if that center is bigger than this large diameter, we're going to break out of there. So it should probably be something calculated from this large diameter. So I can do that. I can say equals large diameter minus small hole plus 2. So let's do that. I'm just thinking, I'm sort of making this up as I go along, so just bear with me a little bit. I'm going to make that small hole plus 2 in parent, so it adds 2 to it to start with. So now that would be my center. So I can go back to the sketch, and I can dimension this guy and call that equals spreadsheet. Get my mouse out of the way. And small hole. So now those are that 10 millimeter. And then if I do a dimension here, so my dimension is going to go, I need to just move that. Let's get rid of that. So I'm going to go from there to there with a dimension, and that's going to be equals spreadsheet small hole center, and I need to make sure that they are symmetrical. There we go. And they should always just be inside there a little bit from that calculation that I did. So if I close that, there's my small holes. If I make my holes a bit bigger, they should stay inside. They stay inside that edge by that 2. If I make that 5 maybe, just to keep them inside. I don't like 5. I like 10 better. There you go. So now those holes are completely set up that way too. So if I change this to be 160, you'll see the hole center's changed too. So you can, once you have your spreadsheet, you can modify it, you can add things to it, you can make things parametric and reliant on different dimensions. So again, I like spreadsheets, but I don't use them as much as you might think, because if I'm designing something, I'm creating it unique, a unique part, and so I'm not going through the spreadsheet mode. Now, afterwards I might do that. Once I've designed it and decided that's what it's going to look like, I might create a spreadsheet of the part at that point. So I hope this has helped you to see the difference between a master sketch, a spreadsheet, when to use the spreadsheet, how to create a simple model. If you've enjoyed this video, please give it a thumbs up. If you haven't already, I'd appreciate it if you'd subscribe to the channel. I also appreciate if you consider becoming a patron, and obviously the links below in the description. Drop me a comment and let me know what you think of Master Sketch or a spreadsheet, which you would use, why you would use it, when you would use it. I'm interested to know how you guys approach modeling and how much you use spreadsheets.